This is introductory video 3, and it's kind of another uh, introductory concepts to the course. It goes questions 1 through 25, but typically they're kind of going through some definitions that we might need for the class. Okay, so in a survey of 597 subjects, the following question was posted on a newspaper's website. In your view, are nuclear plants safe? The survey subjects were internet users who choose to respond to the question posted on the electronic edition of the newspaper. So they're basically saying it's flawed because it's a voluntary response. So they want us to kind of identify this stuff here. Okay, so we read through that, but in the end, they just want us to kind of identify one or two, characteristics about it. It is flawed because it is a voluntary response. So most people have IQ scores between 70 and 130. For approximately $39.99, you can purchase a PC or Mac program from High IQ Pro that is claimed to increase your IQ score by 10 to 20 points. The program claims to be the only proven IQ increasing software in the brain training market, but researchers could find no substantial data supporting the claim. So suppose that in a study of 12 subjects using the program, the average increase in IQ scores is 15 points. There's a 3% chance of getting results if the program has no effect. Yeah, there's a 3% chance of getting such results if the program has no effect. Does the IQ increased software have statistical significance? Yes, the software is statistically significant because the results are unlikely to occur by chance. So I'm kind of going through this. These are not too productive. I mean, it would take a long time to explain one question, yeah. But we're talking about no software in real life, no software. If there's no software involved at all, we have a 3% chance of increasing our IQ, which means there's a 97% chance. We cannot say words like spontaneously, but there's a very high chance, like 97%, that our IQ is not just going to increase by such a substantial amount. Therefore, it is assumed that the software has some sort of statistical significance. So before us, statistics, they're just testing us on some of the kind of common sense things here. Does IQ increasing software have practical significance? Yes, the software is practically significant because the number of IQ points gained is large enough to be considered particularly significant. So these are not really analytical questions. They're more kind of common sense questions. Refer to the table of body temperatures. Is there some meaningful way in which each body temperature recorded at 8 a.m. is matched with the 12 a.m. Temperature? 8 a.m., 12 a.m. Subject 1, subject 2, subject 3. Yeah, so they're going to consider these match pairs. They're just telling us that we have subject 1. Yeah. Okay, good. So this is our sample size n equals 5. So we start introducing the actual concepts. Subject 1, subject 2, subject 3, as we know. But they measure subject 1 at 8 a.m. and then 12 a.m. They measure subject 2 at 8 a.m. and then 12 a.m. So they do this correctly. You have a certain number of subjects and each of them are measured once each at each of the times. So if we kind of read through it, they're just going for that. I can kind of go further in the course. I've assisted with many stats courses, so I know, but they are kind of introducing just some introductory concepts that will go with some of the harder questions later. Yeah. So several studies show that after drinking coffee, subjects had increased blood levels of antioxidants. Antioxidants have been associated with decreased risk of heart disease. A coffee company finances this research. Identify what is wrong. So several studies show that after drinking coffee, Yeah, subjects had increased blood levels of antioxidants, etc. So it is questionable that the sponsor is coffee company because the sponsor can be greatly affected by the conclusion. I think all of us can kind of understand incredibly simple things, but we have difficulty communicating it. So, it doesn't really matter how we say it, but we're basically talking about the obvious thing here that coffee might increase, our activity of antioxidants, which is good. A coffee company finances this research. What is wrong with this? So we select B. It is questionable that the sponsor is a coffee company. That's not really what they're saying. It's questionable, that it's allowed to be a coffee company or something like that is what they're saying. But they're basically saying because the sponsor is a coffee company, it makes the entire study obviously questionable because their profits increase from it. So these are just, there's going to be more of these later, but they're very silly. We don't have to communicate it that well. So if we go through a lot of these, they're more or less kind of the same thing. Uh, we can't really say that all surveys are voluntary response. Um, can we say that all surveys are voluntary response? But the sample is voluntary response is something that very often comes with a survey. Yeah. Okay, so the context of the question, of course, means understand, what the question is talking about, things like that. Yeah, but we don't always have to understand it that well. They're saying that we have a sample size n equals 1286. Yeah, so 0.62 of 1286, right, is going to equal 797.32. In real life, of course, we have to round that because we cannot have a decimal of a person. A sample size is always going to be an exact value. Yeah, always an exact value right there. But they're just asking us if we understand that. Later, we have a p hat, which is sample proportion, is going to be x over n. N is the sample size, where x is the number out of that sample that fits some characteristic. Multiply both sides by n, and x equals p hat times n, which is what we have. We have a proportion, and we have a sample. So if we multiply those, then we get the x that was used for that. So then they're saying here for part C, so they do something here. So here we find the p hat. Let's just say that n is going to equal 1286. 81 is what we're going to call an x. So it's some characteristic out of n. Among 1286 respondents, 81 said that a bended knee is corny and outdated. The subject matter is not important, but the proportion, sample proportion p hat, which is x over n, 81 over 1286, is it going to be approximately 0.06? And yeah, we get 0.063 and all that, but we just want to round to that right there. So voluntary response is a big thing. We can always kind of read through these things here. I just want to kind of get the gist of this assignment here. If we kind of run through, yeah, so we can kind of read the thing if we want. For the findings of statistical analysis of data to be statistically significant, if I didn't read that thing, it's actually you gather a sample size n, and it makes some sort of a claim about a population. But the likelihood of getting those results by chance is very small. Okay, that's good too. So which of the following is not a misuse of statistics? Utilizing valid statistical methods and correct sampling techniques. Okay, so statistics and parameters. So we can kind of talk about this right now. Yeah, but we go over all of this again later. So a parameter, yeah, a parameter describes any value from a population. Yeah, maybe we should kind of write it like this. This is population. And usually capital N is the size of the population, but then we have a lowercase n, which is going to be a sample. Okay, so if we kind of keep this short, a parameter is any value that describes, it's a number, but it's any value that describes a population. A sample, I'm sorry, a statistic, I know that we're not always used to thinking in these terms, but a statistic is going to be any value that describes a sample. Yeah. So mu, that's a Greek symbol mu, is population mean. Yeah, x barred, that's sample mean. Yeah, x barred is sample mean, that's going to be a statistic. Mu is population mean, that's going to be a parameter. So it's as simple as that. Any number that describes any value that describes the population is a parameter. Any value that describes a sample that comes from a population is a statistic. So what does most common mean? This is not R, this is Greek symbol sigma. Yeah, so Greek symbol sigma is going to be standard deviation. We cannot say SD, we can't, because SD is more representative of sample, but standard deviation. So why not S? Well, S is going to be sample standard deviation. That's a statistic. Yeah. So proportion is just P for population. Yeah, proportion or something. This is not all of them, but this is a lot of them. P hat is going to be sample proportion. That's a statistic. Yeah, and then there's more, but so blah, blah, blah. Any value that describes a sample is a statistic. Any value that describes a population is a parameter. Yeah. Okay, good. So we kind of start getting into the class now, just a little bit here.